This is Hanisha. I am from Group 8 and I am going to explain about the top-down mapping and bottom-up mapping and also about the histogram analysis. And coming to the top-down mapping, in the top-down mapping, discretization starts with a single interval. In the top-down mapping will be done by using a single interval, and in the each step, one boundary is chosen. The number of intervals is incremented by 1 so as to maximize the quality of Q of A of the discretized attribute A, and the process is repeated until the quality of Q of a discretized attribute stops increasing, and the time complexity of the top-down approach in the worst case is also of O n of 2. And however, since the number of intervals k is typically k less than s than n, the time complexity is usually in the range of O k of n. And here the each step is chosen with the maximum quality of the discretization attributes, and the time complexity will be O n of 2, and when there are k intervals then the time complexity will be O k of n. And coming to the next line, I will be explaining about the bottom-up mapping. In the bottom-up mapping, the discretization starts with as many intervals as they are learning examples, and subsequently, the two adjacent intervals most similar with respect to the class probability distributions are joined. The process is repeated until the quality of Q of A of the discretized attribution A stops increasing. It will be repeated till the A stops in the attributes, whatever the attribute we have taken. Here we have taken the attribute A. It stops increasing. The process will be repeated, or there are only two intervals left. The time complexity of this bottom-up approach is O n of 2, and n being the number of learning examples. This is about the top-down mapping and about the bottom-up mapping. Here the time complexity is O n, n of 2. And coming to the next slide, I will be explaining about the histogram analysis. Histogram analysis. The histogram analysis is a graphical representation that divides a set of data points into ranges defined by the user. The histogram analysis is a graphical representation. In the right side, you can see the histogram diagram, histogram of multimodal. In the x-axis, we can see the multimodal, and in the y-axis, we can see the frequency. And here, in this graphical representation, the data points are divided by the ranges. Here you can see it is from 0 to 37.5, and then 45 and 52.5. It was defined by the user, and the frequencies are with the 5 intervals: 0 to 5, 5 into 5 to 10, and 10 to 15. And the histogram, which resembles a bar graph in representation, the histogram will look like an bar graph, condensing a data series into a easily understandable visual by many grouping data points into logical ranges or bins. Here the histogram will look like a data graph, and the series, whatever happening in the histogram, will be easily understandable whenever the person was having a look at it. And these lines, which we can see also see in the bar graph, these are called as an logical ranges or bins. And coming to the next slide about the histogram. Continuation of a histogram analysis. Histogram analysis is an unsupervised discretization technique because it is unsupervised technique because it does not use the class information. It has no class information. Various partition rules can be used to define the histogram. In an equal width histogram, the values are partitioned into equal sized partitions or ranges. The ranges or the bins, we can also call this as bins. They will be equally divided with the equal frequency histogram. The values are partitions, so the ideally each partitions contain the same number of data tuples. They are equally divided, so the idea for having them into equally partitions is to have the same number of data tuples. And the histogram analysis in the data discretization, how it is done, and by using the what functions it has been done. For the histogram analysis in the data discretization, we can see in the coming next slide. To perform the data discretization by histogram analysis, we use this function which is called as hist function. His function that computes a histogram of given data values, and the function will provide the number of arguments. By using this his function, we can perform the data discretization. Data discretization can be performed. Thank you very much, and the coming slides will be explained.